Good evening, guys. Just wanted to give you a quick demonstration here on steel weld plates using eddy current. I know it's not really the best setup, but just a quick little demo here to show you that it can be done. It's not super pretty, but it can be done. So, hooked up my probe here, just regular old 1 to 500 kilohertz probe. Like I said, this isn't really the super best way of doing this, but just to show you that you can eliminate some of that noise, you can realize what's going on to see kind of how eddy current will work with steel. Again, it's not necessarily the best, but it can be done, at least in a quick fashion. So, link the probe to my machine here. Okay, then I'm just going to go to main. It's telling me I got a bridge and absolute. I've been piddling with it here for a minute. So I'm going to go to my frequency 1. I'm going to crank this thing up to about 400 kilohertz. That's just where I want to have it running. I've got a horizontal and vertical gain here at 65 and 75. I'm going to run that down to about 40 and 50. Might not be enough, might be too much. We'll have to see what the story is. But I'll let you know here as we go through. Let's go to display and then screen setup. Normal stuff like we always do. We're going to take this. Let's just leave it at 50 and 50 for now to see what happens. I've got my steel test block right here. Okay. Then I would be dealing with normally. I just got my steel weld plates over here that I'm dealing with. Okay. So here's my steel test block. I'm just going to null and air for now. This is going to be the difficult part. My camera situation isn't the best today. So I'll set you here. This is the block I'm messing with. And I'm just going to point you back right over here. Okay. Hit null. I'm right in the middle of my steel block. Okay. You see my line coming off to the left. And if I go across my cracks, you see them come up and to the right, like they should for steel. Okay. Let's back out here so you can see all that at one shot. Get this up here a little bit closer so you can see me re-erase. Okay. Here we are. Nulled in the middle. 1, 2, 3. There they are. Okay. So you see what we got going on. So now we're just going to come back to the screen. I'm going to try and blow this up a little bit. So I'm going to move my screen, my dot, just because this is where I want to run this thing this time. I'm going to put it about 30% horizontal, maybe. If my machine wouldn't have locked up. Darn it. I guess that's what happens after some period of time. We'll do the quick shut off and turn on trick. You know technology, it just happens. So I guess we might as well just deal with it. Give it a second, it'll be live again. Okay, there we go. Log to verify. Got it. Linking. Okay, we're good. Back to main. I'm going to go to my display, screen setup. I'm going to run over here to 30. Down to 20. And just for kicks and grins, I'm going to take that to 20 and 20. Okay, I'm going to erase. Come back down here again. Back you up so you can see what's going on. I'm going to null on the part. Push the null button. There I am. Okay. Don't have a whole lot going on. Push null again. It's kind of going everywhere. So I'm going to go back to my main frequency 1 and take my gains way back down to something manageable. I'm kind of out there in the middle of nowhere. So 40 and 50. Okay, I'm going to re-null. Got everything going down, so I'm going to take my angle. Actually, I'm going to take my frequency up first because I forgot I turned it off already. And that's going to let me re-null. Okay, now we're closer. So I'm going to bring my angle kind of back to the left. I know I'm making a big hook here, but I still want to see my back into the left. It does look different than before because we're dealing with steel. Steel goes the opposite way. So we're going to erase, we're going to null. Okay, there we are again. Back on my part. 1, 2, 3 cracks. Now let's make them bigger. Okay, let's run this up about 50 and 60 just to see what we got. Okay. A little bit bigger. I want to go a little bit bigger yet, so I'm going to go about 55 and 65. Okay, re-null. 1, 2, 3. Okay, doesn't look too pretty. That's because we're dealing with steel. We already know ferromagnetic materials play heck or wreak havoc on our steel crack standard. So let's move that over a little bit to about 50% horizontal so we can still deal with the movement. 50 and 20. 2, 3. There they are. So if we go back now, that's our steel crack standard. That's what we're going to call good for now. We're just going to scan this steel weld plate here. Let me get you turned, backed up a little bit so we can see what's going on. Okay, this is a flat steel plate. So let me set you down here, null on the steel. There we are, nulled on the steel. Okay, here's our liftoff line, kind of just going everywhere. And we can see as we're scanning, we just got a bunch of noise. Okay, just scanning. Whoops, thought I saw something there. Okay, it kind of jumped up and to the right. Wait a minute. Here we go. Okay, again, these are known flaw plates, so I could tell you where the defects are. But as we scan here, I'm watching my dot. I know it's going all over the place, but I'm watching for that up and to the right movement. Okay, I know it's everywhere, and some people like to scan with their compensation on for screen erase, which we could do that. So let's just go to display, screen erase. We're going to turn the persistence on to about half a second. Okay, and then we're going to go back and just scan. Okay, it's going everywhere, it's going everywhere. But we get back to that defect, bam. Okay, pops right back out for us. And we're right over top of him right there. Up and to the right, so we can say, yeah, that's a pretty good sized defect. Get off of it. Okay, there it is, just scanning around the middle. I don't see any big huge movements up to the right. Okay, that's a little persistence. I'm just scanning across here. Not seeing anything, I get back to that defect. There it is again. Okay, just a big screaming defect right there saying, hey, here I am. Okay, so I've got another plate here with a weld bead on it. Okay, back to null, just scanning along. Okay, I want to scan down the sides, scan across the weld bead here. Now one thing you notice, we're back kind of in a weird spot because we got different, not necessarily different weld metal, but the metal itself is a little different. So let's hit the null button. Okay, we're back to null here. As long as we can kind of hang around in there. I know we got crazy signals going on everywhere, but if it's a defect, it's going to pop up like this. It's going to be that big right hand hook thing. Okay, so we're kind of going off the edge of the plate there, but there they are. I mean, that's what our defects are going to look like. That's right off the steel crack standard. So we come back to that so you can see again. Okay, so we're just scanning, just scan right along like this. I'm not seeing any big hooks here going like this. Again, I'm not covering the whole weld bead. We're just doing a quick little demo here. Okay, not seeing anything. Some things that some people like to do, they might like to go here and go, that's not correct. Let's go to display. I always forget sometimes here. Frequency, no, that's not going to do us any good. That's not going to do us any good. Nothing worse than fumbling around here. Filter setup, there we go. Okay, so I'm in my filter here. I'm going to take my high pass filter and just barely turn it on. Okay? That high pass filter is going to keep everything I've got parked right in the middle. Okay, there's my defect signal. Bigger defect signal here, right there. Bigger defect signal here. Okay? But I'm still tied right around the middle now, so all my noise is going on right in the middle. But I know that, so using my high pass filter, if I come back to this plate where I already know it's going to be tied to the center, okay, it's tied to the center, I get over here, again, there's my big crack signal, and I know that because I've got a vertical signal, which is what I'm looking for, especially in ferromagnetics, because I need to separate that liftoff signal from my crack signal. Okay, here's my crack standard one last time. There I am right in the center. Yep, vertical signals. Yep, vertical signals. Okay, So I come back to my weld bead now, which I'm pretty sure doesn't have any cracks in it. I think this is a RT plate, so everything's subsurface. So again, I'm just looking for that big, tall vertical signal, and I don't see it here. So I know it's going everywhere, but that's showing me liftoff of the probe. So I'm not worried about anything going on right there. Okay? Hope that helps. If you have any questions or comments, let me know. Do what I can, and we'll set you up with whatever I can set you up with. Thank you very much. Have a good evening.